Hello and welcome everybody. Today we are going to be talking about inequalities of expressions. Your goal after watching this video today should be able to look at two expressions next to each other and determine which sign or inequality best applies to those two expressions. So we're basically evaluating them in the context of the other one to compare them. So to start off, I took an example question that made me immediately think of inequalities of expressions because degrees Fahrenheit and degrees Celsius. So if you're not familiar, in the United States, generally speaking, we use Fahrenheit to measure how hot it is outside. So for example, the heat wave in California, it's like it was 120 degrees in California this weekend. We're assuming they're talking 120 degrees Fahrenheit. But a lot of times in Europe and in other countries, they might use Celsius instead. So an example of this, I was watching Formula One on Sunday morning, and they often talk about track temperatures. And they're like, oh, it was 43 degrees. I'm like, wow, it seems really cold for the summer. And if I look it up, what I actually saw was that 43 degrees was Celsius. So they were talking about Celsius. How does that help me, though? It's like, okay, 43 degrees Celsius, what does that even mean? So I had to basically do a little bit of conversion and look at our formulas and saw that 43 degrees Celsius is actually pretty hot. So I'm going to put in the Fahrenheit to Celsius formula here. That way we can take a look and see my example and kind of how these two things compare to each other. So if we're looking at degrees Fahrenheit, it equals 9/5 of a degree Celsius plus 32 degrees. So if you're thinking about this expression here, what you should be seeing is that, okay, so if it's 0 degrees Celsius, it's 32 degrees Fahrenheit. And if we're talking about something like 43 degrees Celsius, what they were talking about at Formula One over the weekend, if we were to go through and see how hot that is, so we can do that math quickly, 9/5 times 43, and we'll just get a decimal approximation. It doesn't need to be perfect. And our answer for that is going to come out to 77.4. And if we add 32 degrees to that, we'll get to our final answer here. I want to make sure I don't make a mistake and have to re-record our video of 109.4. So over the weekend, looking at the Grand Prix, it was almost 110 degrees there, so very hot there as well. And this is something that we want to think about when evaluating these two expressions next to each other. So if I'm just sitting on the couch and I want to know for the future, which one's hotter? Is it a degree Fahrenheit hotter? Or is it a degree Celsius hotter? Looking at this formula, what I'm seeing is that we can compare degrees Fahrenheit versus degrees Celsius because it looks like the Fahrenheit number is always going to be bigger than the Celsius number for the same temperature that's outside. So an example is putting these two together, Fahrenheit versus Celsius. When it's 109 degrees Fahrenheit, it's only 43 degrees Celsius. When it's 32 degrees Fahrenheit, it is 0 degrees Celsius. And if we look at our formula, it seems like that's always going to be true because we're going to be multiplying the degree Celsius by something that's greater than 1. So 9/5 is greater than 1 and something like 1.8. So every single time you have a degree Celsius, it's going to not only be 1.8 more for Fahrenheit, but you also add an additional 32 degrees on top of it. So if we were to compare Fahrenheit versus Celsius, we would say that, yeah, Fahrenheit is greater than Celsius. We're going to see that those degrees for the same temperature, Fahrenheit is going to be bigger. So that is kind of a work through more math-based example, but if you're ever thinking about international travel or you're just watching a sporting event that might be taking place in a different country and you need to understand like 43 degrees Celsius, that's not cold. If it was 43 degrees Fahrenheit, that'd be reasonably cold. You want to put a jacket on. If it's 110 degrees Fahrenheit outside, you're not putting a jacket on. So 43 degrees Celsius, same kind of idea. So one real life example of comparing two expressions here and looking at Fahrenheit versus Celsius again, comparison, this helps us. And let's get into our skill for today. So inequalities of expressions is our vocab word. And this is when we are evaluating expressions to determine whether they are greater than, less than, or even equal to, or any combination of those things together. So the big idea for this, again, with Fahrenheit and Celsius, again, we determine that Fahrenheit is greater than Celsius. Looking at the expressions of those two temperatures, we know that one is for sure greater than the other. So this is our comparison. That is our inequality. And then our two expressions that we're comparing there are degrees Fahrenheit and degrees Celsius. So all these questions, for the most part, really are applied examples, and they really do rely on word problems. So for your first step, annotate always. So annotating the question, highlight parts, mark it up, make sure you have all of the relevant information, because if you don't read something correctly, it is really going to affect whether or not you have the correct inequality. Next, you want to determine, after annotating, which inequality are you going to use. So after reading about Fahrenheit and Celsius and basically evaluating both of them, I was like, okay, I know for sure Fahrenheit is greater, so greater than was my symbol. And then finally, compare the expressions using your inequality. So that's your last step, just making a general statement. So say, for example, my wife walked in and she was like, they just said 43 degrees on the TV. It must be really cold. And I could say, nope, I've already compared these. My final answer, I know, is that Fahrenheit is greater than Celsius. So I could tell my wife that the degree measure in Fahrenheit would be greater than Celsius every time. So there's a truism that will always work. All right, so a couple example questions for today. They kind of get a little bit progressively more tricky as you go on. So again, any questions, definitely be reaching out. But the big idea for these is that we're taking a look and we're kind of reading a question, annotating it, and then intuitively trying to understand which one is greater, which one is less, or are they actually equal? So let's start off here. Our first given is that x is bigger than y, and they want to know which one is larger. So we're trying to write a compound inequality using greater than here. So if x is bigger than y, that means that if we add 2 to x, and let's do an example here. So we know that x is bigger than y. So if I had an example chart, we would know that like 2 is greater than 1. Okay, because x is greater than y, so that works. So let's try it. So if we add x plus 2 versus y plus 2, 2 plus 2 is 4, 1 plus 2 is 3, so it looks like 4 is greater than 3. Okay, so it looks like my x plus 2 is greater than y plus 2 in this situation. And we can try a few more examples to plug in, but as long as this up here is true, as long as x is greater than y, because we're just adding 2 to whatever it is, we know that if we add 2 to a number that's bigger, that expression has to be bigger. So we know that x is bigger, so that means that this expression has to always be bigger. So x plus 2 is greater than y plus 2 is our final answer. We know that x plus 2 will always have a larger value. So that's an example of working through one of these, and you can see it's a lot of reading and interpretation and just kind of thinking about logically which one has to make sense. My advice to you is to plug in some values and see what works. And if you're plugging them in and it works, then that's awesome. If you ever get an answer that's equal to, try a few different values. And basically for everything, try a few different values just to make sure that what you plugged in worked, basically. The reason why I only did 1 here is because I was confident. I was like, okay, I'm adding 2 to a number. One of those numbers is bigger, so when I add 2 to a bigger number, the answer is always bigger. Logically, that one perfectly made sense in my head, so I felt good with moving on. But if you're ever not like 100% sure, try plugging in positive numbers, try plugging in negative numbers, try plugging in 0. And if all the conditions meet, then you should be pretty confident in your answer. So basically the idea for this one, read about it, plug in some values, and then see what your final conclusion is. As always, any questions, let me know. Thanks.